Hi, Professor Young back at you here, and in this video we're going to talk about graphing linear functions, standard form for linear functions ax plus by equals c, and the concept of slopes of lines. Now notice the word linear actually has the word line in it, and we were solving linear equations in the first chapter, so now we're going to do some other interesting things with them. Now, in your supplemental handouts, in Angel, and if you're a lecturer or hybrid student, you were given this. You have this handout which will help you with linear graphs and equations of lines and all kinds of good things. So notice the first box is what we're going to discuss in this video, standard form, ax plus by is c. And notice in standard form, you can have no fractions or decimals for the a, b, and c numbers. All right, so these numbers must be non-fractional or decimal, and they like to keep this a number positive. So the first number is usually positive in this standard form, so things to stay aware of, and we'll probably be hitting this as we go through. And the best way to graph in this form is to find what's called the x and the y intercepts. So to find the y-intercept, we're going to let x equals 0 solve for y. To find the x-intercept, we're going to let y be 0 and solve for x. And then all you need is 2 points to graph any line. But we can get more points, as we'll see. And then later on in the video, we'll look at this slope formula and where it comes from. So a linear function, a function f is linear if, for real numbers a and b, f of x or y equals ax plus b. So it says graph the function f of x equals negative 2x plus 6, give the domain and range. So the x-intercept is found again by letting f of x or y be 0 and solving for x. So what we did is, if you want to, you can call this f of x, y here too. So we just plugged in 0 for y, we solve for x. And if you want to write that as an ordered pair, it would be 3, 0. So now it says, since the x-intercept is 3, we plot 3, 0. The y-intercept, we're going to go ahead and plug 0 in on the other part there. So if we plug 0 in for x, we get 6 for y. So plugging in 0 for x will give us the y-intercept of 0, 6. So if you think about this, if you plot that point 3, 0, it's going to be on the x-axis, so that's where the line's going to cross x. And the y-intercept 0, 6, when you plot that, will be on the y-axis. So that way you know where the lines are going to cross here. So there you see, when you plot the 2 points, you can see a line. You can go ahead and connect the dots. Now they also just put one more test point in here of 2, 2. Now you could put as many x values as you want in here. You could put f of 1,000,000 in for x and get a y value. So they just used a checkpoint here. So they said, let's find f of 2 here. Let's try when x is 2. And we would get negative 2 times 2. Now remember to lock in those variables when you evaluate functions. Plus 6 would give us negative 4 plus 6, or negative 2. Or I'm sorry, positive 2. Almost a brain fart there. That's what I call that. It's a student brain fart. My Ouija board there kind of went off there. So when x is 2, y is 2. And we can also put in other values for x and see points along this line. Now notice if we look at domain and range, both of them are from negative infinity to infinity. And most lines are this way. So as this thing extends forever and ever along x, it's going to go both left and right forever and ever, covering all x values eventually. That's what those arrows mean. And on y, it's going to keep going upward and downward from positive infinity and negative infinity. So that is the domain and range. All right, it says graph the next function, y or f of x equals negative 3. All right, now notice, and it says give the domain and range. Now notice on this problem here, if you wanted to make a table of values here, y, or f of x, is always negative 3. So you could put negative 3 forever in here, and then any x values you wanted to. And whenever you graph y equals some number, it's always going to be the graph of a horizontal line. Okay, now notice the domain on this one. Since it goes left and right along x forever, negative infinity to infinity, while the range is simply the number negative 3 forever and ever. And what was the slope of this line? It would be a slope of 0 when we get there. It would be the old constant function. Now, if you graph the line x equals negative 3 and give the domain and range, you can also make a table of values here. So if you ever get confused on which way a horizontal versus vertical line goes, just go ahead and put a whole bunch of x values in that are always negative 3, and then you can put anything else in you want for y, and you will get a vertical line here. So notice here, the domain would be, well, negative 3, the x values, while the range is going to be negative infinity to infinity. Now, this would not be a function, would it? Because a vertical line does not pass the vertical line test, and we would have x values the same, not differing, all over the place. So they're saying here, not a function. Okay, let's graph this equation in standard form. 4x minus 5y equals 0. Now notice here, if we find the x and the y intercepts, if we plug 0 in for x, we get y is 0. If we put 0 in for y, we get x is 0. So, oh my gosh, Young, how are we going to graph it? We only got 1 point. We need another point. Now again, you could put any point in for x and y that you wanted. So what I chose here, I just said, well, let's go ahead, since we know 0, 0's on this graph. It's both the x and y intercept. And let's put some other value in for x here. Let's let x be 5. I mean, and you could pick any x value you want and try it. And I bet you'll get a point along this line as well. So we'll put 5 in for x. We'll say 4 times 5 is 20 in this equation. So 20 minus 5y equals 0. And if we want to go ahead and solve this here, we can subtract 20 from both sides. They don't really show this in here. Let's show this and show we have good habits. Negative 5y equals negative 20. So dividing both sides by negative 5, y is 4. So when x is 5, y is 4, and we have our second ordered pair. And we can make our line. All right, let's talk about slope next. Now, an important characteristic of any straight line is its slope, a numerical measure of the steepness of a line. Geometrically, it may be interpreted as the ratio, and I know a lot of you have heard this one, is rise to run, rise over run. Use 2 distinct points. The change in the horizontal distance is x2 minus x1, donated as delta x. The little triangle here is a symbol change in x, or delta x. It's a Greek symbolization. And the change in the vertical distance y2 and y1 is known as delta y. Oh, the stuff you learn in here. So there is the definition of slope. Now remember, this was given way back here on the old handout. So we're looking at this box right here now. Given 2 points, x1, y1, and x2, y2, we can find the slope. And they put the delta y or over delta x, the change in y over the change in x here. So given any 2 points, we can find this. So notice it says the slope of any vertical line is undefined. So let's just take a few points on this line here if we were to graph it. And I'm just going to take some values here. Now, I would say, let's say this point is 3, 0, and this point is, I don't know, 3, 7. Now, obviously, the x values, whatever you choose, is going to have to be the same if you were plotting this. All right? And it doesn't matter which point you call x1, y1, or x2, y2. So I'm going to put in x1, y1 here. Every point has an x and a y. And I'm always going to encourage you to label those. And x2, y2 there. And notice if we did that formula, y2 minus y1 over x2 minus x1, this is to find the slope of any line, what's always going to happen is that you would have 7 minus 0 over 3 minus 3 here, substituting those values in. Look what the denominator's coming out. That's an undefined fraction, thus an undefined slope that will tell you that line will be vertical. All right, now let's try to find the slope given 2 points here, -4, 8, and 2, -3. So again, whenever you do these, and I am going to give you one of these on the test, is make sure you label the points, x1, y1, and x2, y2. And then plug it in, plug it in. So we're going to come over here and say slope m. Okay, that is the letter that determines slope. Why didn't they call it S? I guess because S looks too much like a 5. All right, is going to be y2 minus y1. Oh, watch your signs here. I could see sign errors going crazy. Over x2 minus x1, 2 minus -4. So notice we get a -11.6 as our slope. And we'll just do a few more of these. Now notice on this one, if you label these 2 points x1, y1, and x2, y2, you get an undefined slope, so you know we have a vertical line. And if you want to, you can get a piece of graph paper and plot those 2 points, and you will see that that's true. All right, well, how about this one then, Young? If we find the slope here, notice the top comes out 0, labeling these again, x1, y1, and x2, y2. Now, if the top is 0, you get 0 as the answer. All right? So this one would be the horizontal line or the constant flat line function. All right, so the slope of a horizontal line is always 0. So let's just review all these different types of slopes. So I can just look at a line and I can tell you that this one's going to be a slope of 0. This one, if it's vertical, is going to be the slope is undefined. If it increases from left to right, you're always going to have a positive slope. And if it decreases from left to right, you're going to have a negative slope. So you can just look at lines and tell what their slopes are going to be. And there is what I just said in terms of words. All right, now this one it says, find the slope of the line y equals -4x minus 3. Now they really do this the hard way. I mean, they go ahead and they find a couple different points, putting in values for x here and getting y's, and you could get any 2 points, and then they label it x1, y1, and x2, y2, and then they go ahead and they figure out the slope is -4. Now, in future lessons here, let me go back to this, this graphic here earlier. We are going to see that we're getting to this middle box down the line, slope-intercept form, where y equals mx plus b. That number in front of the x we're going to find is the slope, and then the b is the y-intercept, the number after the x, so if you solve the equation for y. So if you look back here, we could have looked at this one and just told in this form without getting points that the slope was -4. So some brilliant mathematician must have realized this as they kept doing this more difficult way to get the slope. I mean, if you solve for y, the slope is that number right there. All right, let's graph one here, and we'll conclude this episode because I don't want to make these videos too long for you. Graph the line passing through the point -1, 5, and having the slope -5/3. Now remember, we can call the slope rise over run. So on a negative, you can call this negative 5 over 3 or 5 over negative 3 because you've got a negative there. And it really doesn't matter, and we'll do it both ways just for fun. So starting at the point negative 1, 5, if we call the slope negative 5/3, notice we would go down 5, which is the change in y here. So if we're thinking about this, rise over run, remember the rise is always the change in y. If it's positive, you're going up, negative, you're going down. That's why we're going down here. The run is the change on x. If you go right, it's positive, left negative. So we went right there, negative 5 over 3. But watch, if I would have said 5 over negative 3, we could have also went up 5, but we'd run out of graph, and over 3, so young, you're silly, and that line would have went through there anyway. So either way, I would have had you. So this was standard form and slopes. Bob Young signing off.